Okay, so it's all fine and well to talk about differential equations and water flow, but at some point we actually have to go measure something. And in fact, what we need to measure oftentimes is the water content. So if we're going to measure the water content, what are some of our options? The first thing we could do is use what we call the gravimetric method. And what we're going to do here is we're going to report the amount of water mass per unit soil mass. So it'll have units of grams of water per grams of dry soil. Okay? And all we'll do is take a little sample of soil, and we'll take it from the field when it's wet, and we'll weigh it, and then we'll dry it, and then we'll weigh it again, and we'll get the change in weight from wet to dry, and that'll be our amount of water in the soil, and then the dry weight will go in the denominator, and there we have our gravimetric water content. We could also use a volumetric water content. If we knew this had a volume V, then we can convert our grams of soil to, since the density is approximately 1 gram per cubic centimeter, into a volume of water. Okay. And instead of using grams of soil, now we're going to use the volume of that container, and we just have the volume of water divided by the volume of soil. And this would be called the volumetric water content. Okay, so now we have two ways to represent soil moisture: by the mass or converting to volume and using the volumetric. So gravimetric and volumetric. The next thing we would do is use some indirect method. So we can stick a probe into soil and see what the probe reports. And let's talk a little bit in a second about how that might go.